In this video, we're going to take a look at the notes for linear inequalities and absolute value inequalities. This one's part one, so we're just going to do the first couple of objectives. In this section, it's really important to understand new types of notation for what our values for x can be. And so we're working with real numbers here. And so what we're going to do is we're going to translate this sentence on the left, and I'm going to show you set builder notation and interval notations as another way to express our solutions. Okay, so first off, we've got all real numbers between a and b, but not including a or b. Okay, so we're going to use set builder notation is going to use brackets, and we're going to say for all real numbers x here. This is not exactly how I want this curly bracket to look. Okay, all real numbers of x. So it's going to be between a and b, but not including. Okay, so that means that x is going to be greater than a, but less than b. Curly bracket. Okay, so that's how we do our set builder notation. This might look somewhat familiar, this part. Interval notation is a little bit more simple, and maybe I'll do this in red. This is the notation that we're going to be using more often than not. So we're going to say parentheses a, comma, b, parentheses. So that means that we're going from a through b, and the parentheses here means that it doesn't include a, and this doesn't include b. So all values between a and b. Okay, we'll see some examples shortly where this all makes sense. All real numbers greater than a, but not including a. All right, so set builder notation, we use the curly brackets here. We say all real numbers of x here, and we're going to say greater than a, but not including, so that's going to be x has to be greater than a. And then close it with another set of curly brackets. So the way we can say this is that starting at a, if it's greater than a, that means it's going to go to infinity. Whenever we use infinity, we always have a parentheses here, and it's not going to be a square parentheses, just a curved one. All real numbers less than b, but not including b. Okay, less than b, but not including. All right, so that means we're going b and everything less towards negative infinity. Let's fix that. And it doesn't include, so it's not a square bracket. All real numbers greater than a, including a. All real numbers greater than a, including a. So we're going to use greater than or equal to here. Okay, so now we're going to use our bracket because it includes a and goes to positive infinity. All real numbers less than b, including b. All real numbers less than b, including b. And this is going to be, so we're going negative infinity, and we're including b, so it's going to be a square bracket. All real numbers between a and b, including a. Okay, so all real numbers between a and b, including a, but not including b. All real numbers between a and b, so we're going to do a, including a, but not b. So that's going to be including a, is a square bracket, not including b. This is a curved parentheses. All real numbers between a and b, including b. Okay, so this time we're including b, but we're not including a. So b gets the square bracket and a the parentheses. Okay. All real numbers between a and b, including a and b. Okay. Okay, so there's set builder and our interval notation. All real numbers less than a or greater than b. Okay, so we have an or here. We have x is less than a, or, whoops, I gotta put an a in there, or x is greater than b. And I gotta, forgetting the rest of my curly brackets here on all these. Okay, so we need some space here because we've got to put two statements here. So we're going to a, doesn't include a, so it's less than a going to infinity, or we're going to use this union here symbol, it's u, and we're going from b to infinity. So it's less than a to infinity or greater than b to infinity. All real numbers. So for set builder notation, we can just say x is all real numbers. Just kind of write it out. For interval, it's a lot easier. We just say negative infinity to infinity. Okay. So there are some good examples of the two types of notation that we use to express what our values of x can be. Example 1, we're going to use interval notation to indicate all real numbers greater than or equal to -2. Okay, so we've got, so if I were to, let's say, or to make a little picture of this, so numbers greater than or equal to -2. So I got 0, -1, -2, and -3. And then we're saying all real numbers greater than or equal to -2. So I'm going to do a closed circle, and then I'm doing everything to the right, just like that. So the way we would write that is we would say bracket -2, this is our interval notation, comma, infinity. Let me write that better. Okay, so bracket means include, and that is a closed circle there on my number line. Okay, using interval notation to express all real numbers less than or equal to a or greater than or equal to b. All right. You know what, maybe it's easier if I make this, say I make it a lighter blue, and then we'll go 0, -1, -2, 1, 2. So what are we doing? We're saying right, less than or equal to -1. So it could be equal to. So I'm going to do a closed circle here. And I'm going less than. So it's this way. And then or greater than or equal to, let's say, less than or equal to -1 or greater than or equal to 1. Greater than or equal to. Okay. So let's see what we have here. This is going negative infinity. And we're going all the way including -1. So bracket. Okay. Or it could be 1 going to positive infinity. Okay, that's how we would write that one. Illustrate the addition property for inequalities by solving each of the following. Okay, so addition property, we're just going to add 15 to both sides. Don't have to do anything with the signs here. We're just going to keep them as they are. So it's going to give us 19. So that means on our number line here, we would be at 18, 19, 20, and we'd be an open circle, and we would be shading everything down to the left. So the way I would write that in interval notation is negative infinity to 19, and it's not including, so that would be parentheses. Okay, this one, I'm going to add 1 to both sides. So I've got this. X is greater than or equal to 7. If I want, I could rewrite this, just switching the sign so it still reads less than. And then I'm at 6. So let's go 6, 7, 8. So I'm including 7 and everything less than. So if I write this in my interval notation, it's negative infinity to 7. We're including 7, so I'm going to use a bracket. Okay, now I'm going to subtract 7. X is greater than 2. I hope this is straightforward for everybody. We got 0, 1, 2, 3, 4. We're greater than 0, so open. And we're graphing everything to the right. It's greater than. So we're saying not including 2, but we're going to infinity. Okay. Multiplicative property. Illustrate the multiplication property for inequalities by solving each of the following. Okay, so I have 3x is less than 6. We need to undo the multiply 3 by dividing it. X is less than 2. Doing a little bit more here than it's asking by showing the number line and writing the notation, but I think it's worth it. Get a visual. Doesn't include 2. It's everything to the left. So this means I'm going from negative infinity all the way up to 2, not including. Okay, got a couple steps here. First, we're going to get rid of the subtract 1 by adding it to both sides. Negative 2x is greater than or equal to 6. Okay, so now we have to be careful here. Dividing both sides by negative 2. It's going to cause the signs to switch. So we get negative 3. So x is less than or equal to negative 3. So it can be negative 3. And it's going to be everything less than. Going that way. So we're going negative infinity here. And we're going up, we're including the negative 3. It's going to be a bracket. Okay, last one on this section. Solving for x. First, let's get rid of the 5. Now we're dividing by a negative 1. That's just going to change the signs and the inequality here. Okay, so x is less than negative 5. Negative 3, negative 4, negative 5, negative 6. So we're saying open circle on the negative 5 and everything to the left. That one's done. Okay, plugging away here. A couple more. Example 5, solve an inequality algebraically. Okay, so we have x's on two sides of the equation. How about, I'm just going to rewrite it. I think I'm going to subtract 13 on both sides first. So I've got negative 7x is greater than or equal to 10x minus 17. Now I'm going to subtract 10x to both sides. So I got negative 17x is greater than or equal to negative 17. And now I'm going to divide by negative 17. This changes the signs and we have to flip the inequality. This is positive 1. Oh, it's not a line. So we're at negative 1, 0, 1, 2. We're including 1. And we're saying everything less than. So in interval notation, we write like that with a bracket. Okay. We've got some fractions here. So we know how to deal with fractions. We could do the common denominator and all that, but I would prefer to just clear the fraction. So 4, 8, and 3 go into what number? What's the smallest number that 4, 8, and 3 go into? So 4 times 3 is 12, but 8 doesn't go into 12. 8 times 3 is 24. 4 does go into 24. Let's multiply everything through by 24. Okay, so 4 goes into 24 6 times. 8 goes into 24 3 times. 3 goes into 24 8 times. Okay, so 6 times a negative 3x would be negative 18x is greater than, so we got 3 times negative 5 is negative 15. Then here we have 8 times 2x is 16x x. Okay, so let's subtract 16x to both sides. So that gives us negative 34x is greater than or equal to negative 15. I'm going to divide by negative 34 to both sides. Okay, so it's going to change this sign, and this is going to be a positive 15 over 34. Oh, so x is less than, so that means we're going from negative infinity all the way up to 15/34, and this included, so we'll do a square bracket there. And that is it for this. Next thing would be our practice set. Okay, everybody, I hope that all makes sense, and I'll see you later.